Hello everyone, my name is Maria Mercedes Tapia and today I'm going to talk about the life cycle cost analysis as part of the CEE 422 construction cost analysis class. First, I'm going to introduce the life cycle cost analysis, then I'm going to define what exactly it is. Then I'm gonna move to the step to complete and perform a life cycle cost. I'm gonna discuss some benefits to execute the life cycle cost analysis. I'm gonna move to this challenge to control the life cycle cost and conclusions to this topic. The concept of life cycle cost analysis began to apply in the structured manner from the 1970s, especially in the United States Department of Defense. Most of the methodologies developed at this stage by the Defense Department were mostly focused on the procurement and logistic process. They didn't include any design and production phase. In the 96, the life cycle cost is defined as an economic calculation technique that allows optimizing decision making and associated with the process of design, selection, development, and replacement of the assets that make up a production system. But what exactly is life cycle cost analysis? The National Institute of Standards and Technology defined the life cycle cost as the total discount dollar cost of owning, operating, maintaining, and disposing of a building or a building system over a period of time. The life cycle cost analysis is a method that is focused on evaluating economic performance of a product through its entire life. It's known as a whole cost accounting or total cost of ownership, which is considered that creates a state of equilibrium between the initial investment and the long-term cost of possessing and operating a facility or asset. There are 5 steps to complete a life cycle cost. First, define all the initial investment costs of each alternative. Initial investment costs are costs that will be incurred before the occupation of the facility of a building. Then we have to define the operation costs, excluding maintenance and repairs costs involved in the operation of the facility. The third step is to define all the future maintenance and repair costs of each alternative. The fourth step in the completion of an LCC8 of a project alternative is to define all the future replacement costs. The replacement costs are anticipated expenditures to major building system components that are required to maintain the operation of the facility. And last, the residual value, which is the net worth of a building or building system at the end of the LCC study period. This is the only category cost. This is the only cost in the LCC where we can see a negative value. On that reduced cost is acceptable in this case. So once all the pertinent costs have been established and discounted to their present value, the cost can be summed to generate the total life cycle cost of a project alternative. After this has been done for all the valuable project alternatives, a summary of the results should be prepared. The summary of the project alternatives should compare the total life cycle cost of initial investment, operation, maintenance, and repair, replacement, and residual values of all project alternatives. What are the benefits of executing an LCCA analysis? A life cycle cost analysis introduces to the owner important concepts that are used to calculate the life cycle cost. For example, sunk, which indicate that those costs are not applicable to the analysis. Another benefit is the maintenance schedule that encourages efficiency. Owners and managers can design a maintenance schedule that doesn't interfere with periods of peak operations. Another benefit is the accuracy of preventive and corrective maintenance budget. and also include fluctuation costs. For example, water and utility costs can be predicted with a greater detail. So analysts recognize that costs of water and utilities fluctuate different than other costs. This cost will be included and considered when calculating costs during the life cycle cost analysis. Moreover, the life cycle costs highlight the importance of maintaining a stockpile of replacement parts of a facility. Having the proper parts ready on hand will expedite maintenance and repair work, resulting in few interruptions to productivity. Another benefit that we can see is the energy conservation is encouraged. The life cycle costs are inclusive of energy costs, thereby encourage architects and developers to design energy efficiency structures or buildings. Long-term cost comparison. By comparing alternative design, is becoming more common as stakeholders work to ensure that the investment is a structure that yields the greatest economic result in a long run. And last, the life cycle costs can be integrated into the staff training. Introducing facility staff to the concept of life cycle cost is the first step to ensure that all employees focus on facility care and maintenance. In particular, staff that should understand how the individual maintenance effort contribute to the longevity of the structure or a piece of a property. There are some challenges to control the life cycle costs. We see that the most difficult problem is the reliable information on historical costs and performance, which is needed for accurate estimation of costs. There is uncertainty inherent in any forecast of future costs and performance when there is lack of information available to execute the LCCA study. We are living in a world of continuous change, so changes in building use, commercialization, new technologies, external economics force the changes and radical the future conditions that the building is faced. In that case, the life cycle cost analysis might indicate that have to be reevaluated, revised, and based on the new conditions and the different designs and operations, decisions that will be referred to it. Another challenge or difficulty is the failure to maintain or keep the commitment to the course of the action implied in the initial strategic decision. There is management, sometimes they are not in the same page, so we can see that increasing costs for repair or renewal are potential threats to the safety and health, as well as the life cycle cost integrity. Conclusions. The life cycle cost is a method that allows comparing different strategies and workflow to determine the most efficient approach using economic analysis. As a result, high levels of performance, safer, and cost-effective projects are delivered. The LCCA aims to forecast the economic impact of possible changes in design, development, construction, manufacture, service, and disposal, giving the ability to eliminate uncertainty and forms the foundation of success. This detailed analysis has a great impact on the total cost of the asset life cycle and significantly affect the possibility to expand the useful life of an asset. Technical economic decisions need to be adopted, in most cases actions related to reliability improvement and maintainability of an asset. There are gaps and limitations when using the life cycle cost incorrectly that can lead to a poor decision. Lack of consistent information on historical costs and performance due to location, time, and different methods used for operations and owner can affect the accuracy of the prediction that will support a cost-effective decision. Therefore, cost data is challenging to compile and analyze. As a result, a comprehensive management system needs to be designed to overcome all the challenges that it's facing the life cycle cost analysis. That's the end of the presentation. Thanks for watching it.